Good day, everyone. My name is Shumile Chabalala, and I am presenting a paper named CNN to BiLSTM Enhancing Setswana Named Entity Recognition, a paper presented at the 2024 CSCE, which stands for Computer Science, Computer Engineering, and Applied Computing. The conference was held on July 2024 from the 22nd to the 25th in USA, Las Vegas. The following is the outline of the study. Number 1 is background and motivation. Number 2, Setswana language background. Number 3, the research problem statement. Number 4, research objectives. Number 5, research methodology. Number 6, the proposed Setswana NER model. Number 7, experimentation and results. And the last one is conclusion and future works. Now, getting to the background and motivation. First, we must understand the named entity recognition, which is the NER, the natural processing language, which is the NLP, and their relationship. Therefore, it is crucial to understand what NLP is. Human-to-computer communication is made possible by NLP, which is a subfield of artificial intelligence and linguistics. Basically, what this means is that NLP is responsible, or it's a system that is responsible to translate computer language to the human language and vice versa. This brings us to the second aspect, which is the requirement to comprehend the functions of the NER system. It is safe to say that NER system can recognize predefined categories like names of people, organizations, locations, medical codes, time expressions, and percentages inside any unstructured text, whether it is obtained from the internet, social media, books, or other sources. While still on the subject of background and motivation, let's take a pre-processing of tweets as a real-world example. For instance, inappropriate words in a tweet can be identified using NER. This will facilitate the deflecting and removal of such tweets. Therefore, this shows the importance of NER in a real-world system or scenarios for any language, especially in our case for Setswana, because when you look at tweets or Twitter, anyone can use Twitter. So even the Setswana people are there. So let's say someone is saying anything bad or something bad in a tweet using Setswana. If their NER or their system is not up to par, it will not pick up that word. So it is very important to have NER of Setswana or any other language in all aspects of life. And lastly, in this subject area, in a paper called A Convolutional Neural Network Model for Setswana Named Entity Recognition that was published in 2023, they developed a model for CNN, and they used the relevant data acquired from SADILA, which stands for South African Center for Digital Language Resources. So in their conclusion, they highlighted a limitation of the study. They say that the limitation of the study is due to the small amount of data set, and they recommended, among other things, the use of fine-tuning pre-trained language models that are based on transformers. And they say that this might increase the accuracy of the model. Currently, their model achieved 94% in F1 score. And as we know, according to the literature, The BiLSTM are frequently used for sequence labeling issues with long-term reliance. And the CNN are primarily used for image data, but also effective in sequence data. Both of these methods can improve the overall training accuracy. So this is the motivation to use the CNN as a custom pre-trained model, which is combined with LSTM as a transfer learning to enhance the results of the study. Just to give a little bit of background on Setswana language. South Africa has 11 official languages, of which Setswana is one of them. Now, according to South African Statistics, which is a government entity that is mandated to provide statistics in South Africa, they did a survey in 2016, which is still relevant even today, and they are saying that 8.8% of population in South Africa are speaking Setswana. And they say the language is ranked 5th in terms of language usage in South African households. Now, according to the literature, they say that Setswana belongs to the South Tswana subgroup of the Southeastern Bantu group of the Bantu language family. And in Botswana, which is a neighboring country of South Africa, they are also speaking Setswana as one of their official languages. As I mentioned earlier, that the NER is used to categorize people's names, places, dates, and other proper nouns as entities within a given text or a corpus. So the NER has been explored significantly for other languages that are resource rich, but only few NER systems for Setswana so far. This is due to the lack of annotated data according to the studies and linguistic resources. Therefore, this makes it challenging for NER systems to be developed for Setswana language. Therefore, this is the problem statement that we have: the lack of annotated data sets and linguistic resources. The main objective of this study is to improve the performance of the NER for Setswana language systems using the transfer learning approaches. Then we have the sub-objectives. The first one is to develop an ontology of named entity semantic features of the Setswana language. The second one is to investigate knowledge-based modeling methods for the semantic features and existing BiLSTM methods for Setswana NER. Then develop a knowledge-based CNN to BiLSTM models incorporating the semantic features. Then the last one is to experimentally validate the CNN to BiLSTM models. Now, addressing the gap of the study, we are currently having few methods that were used to study the NER for Setswana language. One of them is the CRF, which is the conditional random fields, which uses machine learning, and two of them are CNN and BiLSTM. These ones are the neural networks. All these methods, they achieved extremely well, but none of them have ever used transfer learning according to the literature. All these methods will be covered later on in the presentation. Therefore, this paper proposes using a transfer learning to build a model, which is CNN to BiLSTM, to take advantage of the knowledge learned from the custom pre-trained CNN models so that we can improve the quality of the output of our results. For the research methodology, the study uses transfer learning as a method to integrate CNN with BiLSTM. Just to reiterate what I said earlier, CNN has the ability to identify local pattern with sequences, and BiLSTM is able to extract context and long-range dependencies from the text. The dataset used for the study is acquired from SADiLaR, which is South African Center for Digital Language Resources. It contains 230, 736 words that are aligned with their text, which means the dataset has been annotated in 2 columns. This dataset was developed by Northwest University, which is one of the universities in South Africa, within a department called Center for Text Technology for Government Domains. This part of the research methodology shows the steps taken to build the NER system. So in order for us to effect the transfer learning, we load the custom trained CNN model that was trained before from the previous study. Then we remove the last layer, which is the classification layer. This part is called feature extraction. Then next we freeze the pre-trained model layers in order to prevent any information from being lost during the training process. Then from step 1, we load and prepare the data for our new model. We split the data into sequences and tags, convert the text to one hot encoding, then we convert the sentences to sequences of integers and pad them to fixed length. Then we split the data into training, validation, and tests. Then next we show the NER model architecture, which is still part of the methodology. So the architecture goes like this. The first one, we define the model as sequential. Then the next layer will be input. The following layer, the third one, will be bidirectional. We put a dropout. Then we put a layer, global max pooling, one-dimensional. Another layer, which is a dense layer. And then it's activation ReLU. Then the last one is an output layer with activation softmax. And lastly, pertaining the research methodology, we show the platform, the libraries, and the language used. So we used Python language in a Google Colab environment, and then we use TensorFlow as a platform and the Keras library to develop the model. In our experiments and results, we evaluate our results using evaluation metrics. The evaluation metrics consists of precision, recall, and lastly, the F1 score. During our experiments, we tuned the hyperparameters as follows. We have the bidirectional LSTM, which has 64 units, the dropout, 0.5 rate, the hidden layer, which is a dense layer, it has 128 units, and activation as a ReLU. The dense layer, the last one, which is a dense layer, the output layer, it has 9 units. The 9 units represent the 9 tags that we have for our data set. And then we have activation softmax. The batch size is 128 for it to be faster when it processes. And then we have 20 epoch. We trained the model with the hyperparameters that I explained earlier, and we got this classification report. Then it is summarized as 0.96 accuracy, which is also our F1 score. This part of the experiments shows the confusion matrix, which is an error report. This is because in our classification report, we don't have the view to check how our model performed. We cannot see or diagnose the model from there. But with the error report, we are able to see how it performed and how tags were classified. So in this error report, from top to bottom, diagonally, we can see how tags were correctly classified. For instance, looking at the out tag in the top left, we see that 42722 tags were correctly classified as out. Then looking on the bottom left, on the I miscellaneous tag, we can see that this I miscellaneous tag, 802 of them were incorrectly classified as out. That is how we are able to diagnose the model. So by looking at this report, most of the tags were correctly classified when we were training the model. Here we are showing a comparison with other models on Setswana language NER. It means we are comparing the results of our model with what is there in the literature. The first one, it was done in 2020 for CRF, and it performed with the F1 score of 78.06%. The second one, also done in 2020 for BiLSTM, it performed with 75.74%. The third one was done in 2020, same study, BiLSTM, it performed 74.07. And the fourth one, it was done in 2023, the CNN model for Setswana, and it performed 94% of the F1 score. And the last one is the current model, which performed 96%. It was done on CNN to BiLSTM. All these models are using the same type of data set, hence the comparison. In conclusion, the study shows the effectiveness of transfer learning. This is due to the improvement of the results. The results improved with 2% compared to the recent CNN model that was used as a custom trained model. Therefore, it shows that the transfer learning is effective to tackle the issue of low reserves, language, and the lack of annotated data. For future works, we recommend the investigation on error analysis and data argumentation in order to deal with low resource issue. Then this brings us to the end of the presentation. I thank you.